So today we start with the lesson, and we have this question: what the heck? So what's wrong with this sequence? Suppose they start with x equals y. Now imagine we multiply both sides by x. You're going to get x squared equals xy. Then imagine if we subtract y squared, right? When we factor those equations, on the left side we end up with x minus y times x plus y. And on the other, the common factor is going to be y. So we end up with y bracket x minus y end bracket. Now, the next stage, we divide out x minus y. So we actually get rid of it. So essentially, we end up with x plus y equals y. But didn't we say that, well, x equals y? So that means x plus x equals x, which means 2x equals x, which essentially means 2 is 1. Tell me what the heck is wrong with this sequence. Now, some of your responses were good. I'm going to tell you that basically when we do this, we're actually dividing by 0. So you'll note that for step 5, it says we're actually dividing by x minus y. So if we do that, for both sides, we have to follow that same pattern, right? Now, when we divide by x minus y, this cancels with this, and this cancels with this. But remember, when we talked about anything that was in the set Q, so Q were rationals, right? We knew that these things were basically of the form P over Q, where P and Q were integers, right? They were just Z, right? They were integers, but you know that there's one extra caveat. Q was not equal to 0. Now, essentially, anytime you divide by 0, this is a very, very bad thing in mathematics. Weird things come about. And the reason why I showed you this lesson is because when you divide by 0, impossible things happen in mathematics. So please try to avoid that. In this case, we have to say x cannot equal y. We actually have to remember that. So when we did part 7, we actually violated that clause that we should have had in step 5. Because x cannot equal y, it does not work. And because of that, the only solution to that entire problem would have been x equals 0. So what are we doing today? We're going to be reviewing the terms pertaining to solving equations. We're going to take a look at single-step operations, two-step operations, and we're going to focus on the distributive property. How we understand? You're going to be able to work with monomials and binomial expressions, and then what you're going to do is you're going to be able to solve those binomial expressions using SAMDEB, which is just the opposite of BEDMAS for when we're solving. Now, what I want you to do is I want you to take a look at each of these expressions. So anything that's an expression does not have an equal sign associated with it. Any concatenation, any list of terms put together is called an expression. So if you look at the term equation implies there's some sort of equality to the left and right side of our problem. In essence, for this first one, we're saying that the line 2x is equal to 10. So where does that actually happen? So we're actually trying to find the solution, which is really just a point. Moving on, take a moment and just copy down what you see on this chart here. So the key concepts are, when you're solving, you're just determining the value of an unknown. One of the things that we have to do is we have to isolate a variable. It means to just simply manipulate the equation and making sure that one side of the equation just has numbers and another side of the equation just has a variable, or something is isolated, left by itself on one side of the equation, either the left or right. Now, we use the opposite operations of BEDMAS, and we refer to that as SAMDEB for the rest of this lesson. Okay, for this next problem, we're going to continue using SAMDEB. Now, one of the things we have to do is we have a plus on the first part of this problem, plus 12, and we're moving it to the other side. So our result is going to be 56 minus 12. And when we simplify again, we end up with x is equal to 44. Now, for part B, you'll notice that we have 14x equals 56. We know that we want to move that 14x to the other side. Now, the operation in between this is times. The opposite of timesing is division, and division can also be written as a quotient. So we're going to basically do the opposite of multiplication to have division. So we're going to have x is equal to 56 over 14, and that is going to end up being 4. Now, for the next problem, we have 42 being attached to x, which is really 42x divided by 42. So what we're going to do is we're going to do the opposite of that to be multiplication when we move it to the other side. So now we're going to end up with the following. 3 times 42 is going to equal x. When we solve, we end up with 126 is equal to x. And now, for the final problem, I'd like you to try on your own, pause the video, and do your own solution. What you want to do for this last one, we have an alternate solution. You can flip both the left and right sides of our equation. So we're going to flip them horizontally. And then we end up with x over 42 equals 3, because some of you guys just like having x on the left side of our equation. And it still ends up being x is equal to 42 times 3, which ends up being 126 as we expect. Now, for the next problem, I'd like you to try D on your own. Pause the video, and then let's see what we come up with. Alright, for this next problem, what we're going to do is we're actually going to flip both sides of our equation vertically in order to reduce our thinking. Because I tend to like doing problems where I have x on the top of our fraction. So we have x over 42 is equal to 1/3, and then we follow the same pattern as before. Because x is on the bottom, we're basically multiplying. So we end up with 42 over 3, and we end up with 14. Now, the last solution for this could be, we start with our problem, and all we do is we just swap the x and the 3. So we have 42 over x is equal to 3, so we end up with just x is equal to 42 over 3. Either one of those solutions you can use to do these problems, and we end up with 14, just like before. For this next problem set, what we're doing is we're going to use SAMDEB in conjunction with addition and subtraction and multiplication and division. So what we're going to do for now, for the first problem, is we're going to use SAMDEB using the SA part, and all we're going to be doing is just saying 5x is equal to 13 plus 12, because at the beginning we had minus 12. Now, once we get to this last part, we end up with 5x equals 25. And in order to get x by itself, we divide both sides by 5, and we end up with x is equal to 25 over 5, which is just 5. Now, for the next question, we have to consider the lowest common multiple that we have. Every time you see fractions, I want you to do that. Use the lowest common multiple, then use the SAMDEB. Now, For this one, the lowest common multiple is 4, so we're going to multiply everything by 4. And 4 over 4 is 1, so we end up with just x minus 2 left over from that left side. And now we have minus 12 on the right side. So now we're just going to use SAMDEB again. Use this, and we're just going to move the negative 2 over to the other side, and we end up with x is equal to negative 12 plus 2, and we end up with x is equal to negative 10 as our final answer. Now, for this next problem, we're actually using the distributive property. Now, the distributive property is referred to as the distributive law, and we take A and we apply everything to the inside. So we're going to do the same for 3x and x plus 5. So we're going to go and hit 3 into everything here. Now, there's a negative 1 in this second complex that we have here. And what you're going to do is you're going to take the negative 1 and you're going to apply it to everything inside that bracket. So in essence, we have negative 1 times 2x and then negative 1 times plus 2. And then we're going to do the same for the last part. 2 times x and then 2 times negative 1, and we end up with the following line. We end up with 3x minus 15 minus 2x minus 2 is going to equal 2x minus 2. Now, I want you to only simplify the stuff that's on the left side, and you're going to end up with x is equal to negative 17, and then leave the right side, and you end up with 2x minus 2. This greatly simplifies your calculations. So now we're going to move the 17 to the other side, and we're going to get x minus 2x is equal to negative 2 plus 17. So use some form of cancellation in order to keep track of what you're subtracting and simplify. At the final answer, you're going to get x is equal to negative 15. And now, remember, take a look at B. We have to use the lowest common multiple. The lowest common multiple is 12. So we're going to multiply everything in that first line for part B by 12. So every fraction by 12 and every number by 12. So 12 divided by 3 is going to be just 4. So the next one, we're canceling out again. We end up with 3. So now when we rewrite this line, we end up with 4x minus 2 plus 3, blah, 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 all equals 48. Now, you're going to follow the same pattern that we did in 1 where we distributed across. So we end up with 4x minus 8, 6x plus 6 equals 48. Now, collect all the work on the left side, and you should get 10x minus 2 is equal to 48. And now we're going to use SAMDEB to move the negative 2 to the other side. So we get 48 plus 2, and we have 10x on the other side. So 10x is equal to 50. And now we solve for x. X is equal to 50 divided by 10, and we end up with x is equal to 5. And we're good. This next problem set allows us to solve for x. So we're going to use SAMDEB again, and we're only going to solve for x squared first. So we move the 82 to the other side. So we get negative x squared equals 1 minus 82, which simplifies to negative 81, and negative x squared. To get negative x squared by itself, we divide both sides by negative 1. So we end up with x squared is equal to 81. And now, to get x by itself, we write x is equal to 81, but we take the square root of that. And now we end up with x is equal to 9. So just remember, the opposite of a square root is a square root. Now, for the next one, we're going to solve for x squared again. So we're going to get x squared is equal to 64, and we're going to move the y squared to the other side to get minus y squared. Now what we're going to do is we're just going to square root 64 minus y squared. And our answer is complete. There shouldn't be any real difficulties here. Now, what I'd like you to do, and this is your homework for the day. Good luck.